Hello, everybody. My name is Andrew Fonseca. Thanks for joining us today for the New England webinar. We're going to cover Milevision's detection product. Um, I'll just give everybody a little bit of time. I think we have uh, 8 people on right now, but I think we're looking closer to getting 20 or something. So I'm going to jump off. I'll hang tight for a couple more minutes, and then we will get going. Thanks. Okay. Well, first of all, I want to thank everybody for taking the time to uh, join our webinar today. Uh, I'm Andrew Fonseca. I'm with Milevision Technologies. I will do a quick intro to the other presenters that will be also speaking today. Ocean State Signal, thank you for hosting this as well. They are a partner out in the New England area. They are the um, Miovision exclusive distributor in the area. So any questions following the presentation, um, please follow up with Ocean State Signal as they're very close with us and they do all the implementation out in the New England area. Right now we have, I think, a good portion of people on the line. So I'll kind of get it going. If anyone hops in, we'll go from there. Uh, a few kind of housekeeping items. Any questions throughout the presentation, please field them. Actually, please, you can include them in the comment box area, and my colleague Ian will be actually fielding those questions and we'll be addressing them all at the end of the presentation. So any questions you have whatsoever, the more the better. We'll make sure that we allocate enough time at the end of the presentation to address everyone's questions. So as far as who will be speaking today, my name is Andrew Fonseca. I've been with Milevision for about 5 years. I'm an enterprise account executive in the New England territory. I also cover some of the territories in the Midwest, but I've always been in the Northeast territory. So I have a little bit of an understanding of kind of the infrastructure and the needs in the area. So I will be talking through a little bit, kind of a high level of our product, what it does. Ian is my colleague. He is also an account executive in the territory. So we both work in the area with customers on the sales side of the business. And he will be fielding all the questions and doing the Q&A session at the end. And then Rob Molinaro is the technical account manager. He will provide his own intro before he jumps into a live demo, but essentially he's in charge of supporting our customers from a technical standpoint. So kind of we'll get this show on the road. So I'm going to assume that the majority of the people on the call don't know who Milevision is. Some of you may, some of you may not. So Milevision is, we've been around for about over 10 years. We're located in Kitchener, Ontario. We have over 200 employees now, and about 70, probably closer to 100 now, of those members or those employees are actually software and hardware engineering teams. So what that means is we are a software-focused company. We've been on the data collection side for quite some time, pivoted to ITS. We recently went after a capital raise successfully for $100 million, and we're taking that round and we're putting that into innovation. So we've always been a forward-thinking company, and now we have the ability to move faster. And we'll talk a little bit about some of the directions that we're going and some of the deployments that we've deployed in your area. So the Milevision Scout, before I get into the ITS and the detection side, talk a little bit about the Scout, just because I know that it's a pretty prominent product out in New England, whether it's through PDI doing data collection in New England, or it's through Connecticut Counts in Connecticut. We have a ton of these portable data collection systems that are out in the field. If you've seen them, they mount an intersection, they record traffic, they send us the video, we convert that to turning movement counts for signal retiming, for synchro modeling, etc. With those cameras, we've been able to collect about 7 billion vehicles, almost 1 billion cyclists and pedestrians. And we've actually taken all of that data and we've been able to teach an algorithm to actually do detection at the intersection, which is what we're going to be focusing on today. So before we get into the hardware and what it does, I think it's important to talk a little bit about how we built this product and the different pillars of thought that went into building this product. So we break them down into 3. The first one is open architecture. So we've built all of our hardware for compatibility, not vendor lock-in. What that means, it integrates with any types of controllers, cabinets, existing detection, cameras, backup batteries. We just want to make it very simple for cities to deploy this, but also down the road as things change to still be able to use that hardware. So we made it very easy to integrate from that perspective, and on the software side as well. So we have a few different open APIs that can pull our data into different platforms, but we also integrate seamlessly with central management systems. So if in MassDOT District 2, I believe, for example, they have a tactic system. So they're leveraging our communications to pull all that data into their tactic system. So we're really about leveraging the existing investments that agencies have made versus replacing them. The second one is the ecosystem approach. So the ability to make it very simple to provide data to either other people internally or your partners, such as engineering firms. So traditionally, data that's gathered at the intersection has been in a silo. It's very hard to share that data with other people. So it kind of doesn't really foster innovation. So our product is built in a way that, if an engineering firm is doing a signal retiming for a city or a DOT, it's very simple for the city or DOT to serve up all of that data that they need in order for them to make those decisions. Or if there's we've worked with schools in the past. One of the schools on the academia side, they built a app using our data for the visually impaired to cross the street. So the power of data is pretty massive, but it becomes even more massive when you can share that data and leverage, your ecosystem around you to innovate off it. The last is the smartphone model. So if you think back, this analogy our CEO used quite a bit. If you think back to 20 plus years ago, you would buy a calculator, you'd buy a stopwatch, you'd buy a flashlight, portable DVD player, and then the smartphone came out, which was one piece of hardware that was enabled with different software that did different functions. So we've looked at building this the same way. So instead of having a GPS time clock for time sync and a traffic probe for travel time and a router for communicate or a modem for communications and a camera for detection, we've made it so that all of that stuff is actually built in to the hardware. And essentially it just allows cities to pivot and it's future proof. So if you need it for just detection today, we can absolutely do that. But say you take up a Vision Zero initiative and you want safety, then you can use that same hardware to address those concerns as well. So when we look, when I talk about doing different functions, we're not going to go in depth into all of them right away, but I think it is important to know kind of we cast a wide net as far as what we do as a product. So what do we do? So we break it down into apps here. So we can be used for just video detection, and I want to make that clear because Milevision does have a lot of software functionalities that agencies can use, but we also can be used for just detection at no reoccurring cost. So if a city just wants reliable, accurate detection from a video detection system, we can do that. From the signal maintenance side, we can also provide alerts at the intersection, signals in flash, the power goes out. We can integrate with backup batteries to let cities know or DOTs know when they've kicked on. So we can do some of that functionality that maybe a light version of essential management system per se. We also have the ability to provide traffic data from, as far as traffic data goes, it would be 24/7 turning movement counts, head counts. I'll cover some of that. We'll probably show you a live demo of what that looks like at the intersection. We have a whole suite of ATSPMs, automated traffic signal performance measures. So everything from occupancy to split failures to Purdue coordination, depending on the detection that's in the field, we can leverage existing detection for those metrics as well. We have a pretty robust suite of ATSPMs to address traffic congestion. And then we also have a traffic probe built into our system for travel time. So wherever we're installed, we can actually do travel time throughout a corridor. So that's quite a bit of stuff that we do, but there's also this other piece with third parties. And we believe that not one person can create a smart city, right? Or a smart intersection. I think it requires all vendors to be open to work with others to create that environment or that ecosystem. So some of the different things we can do is I mentioned third-party integrations into CMS, so essential management system. It doesn't stop there. If agencies have an MS2 software that they pull data in, I know the DOT pulls all their chain movement counts into there. We can provide a stream into that as well as any other softwares that agencies may have, including, say, a video streaming software like a Genetech or an ExactVision. We can pull our video into there. We've done some integrations with, actually we have a deployment in Quincy, Massachusetts with SureTrack. So it's an adaptive system. So they're essentially using our detection and our AI data. So even our pedestrian and vehicle classification data to do adaptive signal control in Quincy. So that's another integration with a partner. And there's a few others I won't get into, but Blinksy, microtraffic for conflict analysis, just other partners that we can work together with. We also have a division called Milevision Labs, which looks at a little more forward thinking and some of the stuff that is on the roadmap, but not in production yet. So some of the things we looked at there is we've already released some active safety measures, but we're continuing to grow those metrics out similar to our ATSPM platform. The intersection health and emissions air quality, I think it's very important. We can do quite a bit of before and after looking at traffic congestion and changes that are made. But how do we turn that into something tangible that a city can show their citizens or show the mayor? So what does reducing travel time by 3% or 30% mean as far as from an environmental perspective? So those are kind of some of the different ways we're looking at presenting the data. So I think it's also important to know who our partners are. We're partnered with a few big players. One is Amazon, so they use all of our cloud computing and they store all of our data. So we use the Amazon Enterprise Cloud for that perspective. And then we use NVIDIA for our GPUs, our graphic processing units. They're in our device. That's what actually runs our algorithms and runs our machine learning and our AI at the intersection. The other one is Verizon. So we do have cell communications built into our product. We can leverage a third-party communications, but we do have that as well. And Verizon's our partner for cell communications. And then in the US, and TELUS is actually the telecom provider in Canada, and also they're one of the major investors in the capital raise that I discussed a little bit earlier. So I think it's important to note where we're installed. So essentially, we have about 3,500 plus intersections in North America. In New England specifically, we have about 120 plus systems. A ton of them are in, a lot of them are in Massachusetts, but we do have some throughout the other states. Obviously, I was supposed to add a couple more here. I didn't. Sorry about that. But we have about 30 plus intersections in Quincy, which is running that rapid flow sure track technology that I discussed. MassDOT District 5 has about 8 systems out there. I know we're also installed in MassDOT District 2, 1. We're in quite a few of them now. Some of them using us for just detections. Other ones have been using us for detections and communications, maybe even some of the alert functionality. So we have an extensive deployment in Massachusetts and outside of there, and we'd be happy to talk about any of those existing deployments further on another call. So jumping into the hardware now, I don't want to spend too much time on the hardware because I think it's important to show a live demo, which Rob will be providing, but these are the devices that are plugged into the cabinet. So on the left here, you have the Miovision Smart Link. This can be used on its own as a communication hub and essentially a way to access data from the cabinet. So this plugs in to the cabinet and can actually access all your telemetry, detector data, MMU data, and bring that back into our platform or an existing central management system. In the antenna is our traffic probe, which does our travel time. The device on the right is our Smart Sense. So this is where runs our algorithms that allows us to do detection, allows us to do traffic counts in real time, and essentially is the any of the video analytics that we provide come through this device here. So both of these devices do need to be installed to do detection. The third is the camera. So the camera can be used on its own without the detection device for remote monitoring, but essentially you can just look at the camera as a way to tap into the intersection in real time, see what's going on, and also that's what's providing the video stream into the Smart Sense device for us to do detection and traffic counts. And then lastly, Milevision Traffic Link Portal. So we have a cloud-based software that allows agencies to tap in, view their intersections in real time, pull traffic counts, essentially remotely manage their intersections as well as remotely configure their detection. And we'll provide a live example of that shortly. So it's also important to know how we're installing this device. Here's a quick picture. I have a couple of the pictures that Ocean State provided of some local deployments, but essentially the traffic link antenna goes into the top of the cabinet. You drill a small hole, with a 3M seal. Ocean State can provide a ton more information. They've installed over 100 of these in the field. And essentially from there, the cabling comes in through the cabinet into our SmartLink device. Each cable is color coded and quite easy to plug in. One might do time sync, one does GPS, one would be for the traffic probe. They all have a different function. But the installation itself at the cabinet should take about 20 minutes. The SmartLink and SmartSense go into the cabinet. It can go next to the controller. We do have, it's primarily NEMA out in the New England area. However, if it is a 2070 cabinet, we do have ways to install into those as well. But I'll show you another picture of what that looks like. So intersection assessment, between Milevision and Ocean State, we have a strong team that looks at deployments and provides recommendations based on those deployments. On average, we like to be 28 to 30 feet. We've done lower, we've done higher, but this provides a general understanding of how far we can see. So to the back of the zone, you can see anywhere between 180 to 220 feet, between 28 and 36 feet, and about 140 to 180 to the front of the zone versus the back of the zone. We also have an extension. Ocean State deploys an extension that can get it about 10 feet higher. This one here is mounted right on the pole where that red circle is, but I'll show a quick example of what it looks like with the extension. And we can also run 2 cameras off of 1 processor. So in situations where it's a massive intersection, it just requires an additional camera. It doesn't require other additional hardware. So here's a couple pictures of Ocean State deployments. So you can see here we have a Siemens M60 controller. Directly next to it is the Smart Link, and then to the right of that is the Smart Sense. So both those devices have to be installed, as I mentioned, in order to do detection. However, the Smart Link can be used on its own for communications and data purposes. We're plugging into everything here. So we can plug in via SDLC for detection. We can plug in via the GPIOs. We can hardwire in for detection. And then we can also, we can go through NTCIP to pull all of the data. So usually we're on a NEMA cabinet, on TS2, we're going in through SDLC and NTCIP to pull the data, and SDLC to actually actuate the intersections. On the right is our camera deployed with the 10-foot hook, so you can see the Bishop's hook goes up 10 feet. That's on the mast arm. The higher we can get to the middle of the intersection, the better view we have of everything, and the better we can not only do detection, but also actually count the crosswalks as well. So I really want to focus on how Miovision does detection. We do detection a little bit different than, say, it's been done in the past. So the big pieces, earlier in the presentation, I mentioned that Miovision's counted through the Scout portable data collection. We've counted 7 billion vehicles, almost 1 billion cyclists and pedestrians. We've used that to train an algorithm, first model, so to know what does a car look like, what is a bus, what is a truck, what is a pedestrian, what is a bicycle. So at the end of the day, we're actually looking for characteristics of those specific vehicles, and we're making a decision on what that is based on that, not based on size. So as you can see, once a vehicle enters an intersection, we draw a box around it, and we're actually classifying it on the back end. So I'll show this. I'll show you. Rob will be showing this live on the demo portion of the presentation. But I do think it's important to note that this allows us to address things like weather conditions different than maybe in the past. And I'm not saying this is the silver bullet and Miovision's perfect by any means, but what I am saying is there's a foundation that we've built to allow us to improve over time and get better. So what that means is if there's a big snowstorm in New Hampshire and we're having trouble actuating, we can take that data, we can retrain it, and we can push that out into the field, which I'll show you guys what that looks like. But essentially, when it comes to weather, I think it's important to address that in the Northeast in general. And things like a white vehicle in snow would not be an issue with the way we do it, because we're not actually doing background subtraction and looking for pixelization to change. We're tracking vehicles through the movement and actuating them once they enter the zone. So along with the detection piece, there's a couple other things we can do. So we can actuate zones. We can do continuous counts. We can do 24/7 vehicle and pedestrian counts. So we can break them down by bus, articulated truck, light goods vehicles, cars, and then we have pedestrians and cyclists. So instead of having a spot count, we're doing 24/7 turning movement counts and pedestrian counts along the crosswalk all the time, and it's very easy to take that data and dissect it. We're going to do a separate presentation around the data side of things. On the safety side, we released 2 safety metrics recently. It was red light running, as well as pedestrian compliance. I want to make it clear that red light running is not a red light running ticket camera. It's essentially just capturing that data and presenting it back. So cities, DOTs understand where it's happening, when it's happening, and why it's happening, similar to the pedestrian compliance. And it's not to victimize either or make, or at least blame anyone. What we're trying to do is just understand why it's happening and provide the data that allows agencies to make changes to address those and monitor the changes that have been made. ATSPMs, using stop bar and upstream detection, we can provide a bunch of those. We'll be doing a separate presentation and case study that'll go deep into the data and how cities and engineering firms are using Miovision's data to address traffic congestion and safety. And then video management, so the ability to tap into the intersection in real time on a cell phone, laptop, anywhere where you have internet access, and see what's going on at the intersection. So since we run on a cloud-based device, we're essentially able to pull that up anywhere. So it makes it very versatile from a technician standpoint out in the field, or a traffic engineer who may be working from home. Makes it very easy to access video, data, and anything else you may need. You'll notice the big cluster of pedestrians. So we've worked very hard for our algorithm to be able to count pedestrians. We're used as permanent count stations at a few locations or a few different deployments across North America. Toronto uses us solely for permanent count for pedestrians and vehicles in their downtown core. So when you look at having detection and improving over time, how can we make that simple for our customers? So essentially, our equipment gets installed into the cabinet. We take that data, it goes up into the cloud, and then we're able to take that data, we're able to train and continuously learn, and then we're able to essentially validate that those changes have worked, and then we're able to push that over the air to our customers. So what that means is nobody's ever going out with a USB to update version 2.3 of the detection software. Essentially, we push all those updates out over the air for our customers at no cost. And I want to make that also clear is whether or not a customer is using and paying for software versus just detection by itself, where there's no reoccurring cost, we're always updating our algorithms for our customers in the field. So everybody across North America is kind of learning from everyone's environments and improving at the same capacity. So I think, all right, so we're not doing too bad for time. So what I'm going to do now is we're going to switch over into a live demo of the platform, and Rob will kind of walk everybody through a live demo and show you in real time what we can actually do.
Thanks, Andrew. And good morning, everyone. And perfect. We should be on the map screen here. So first, a brief introduction. My name is Rob, and as Andrew said, I'm the technical account manager for the New England area. So my role with Miovision is mostly helping to configure intersections and help optimize the deployment so that we're getting the best detection possible. We're able to see in various different conditions, and our end users can just bounce ideas off me to see what we can put together. What you're seeing here is your default screen when you log into TrafficLink. So you're going to get a map of the local area as well as all the deployments. In this case, we've chosen Quincy. They've been a fairly large customer of ours, and they have a number of deployments at a number of intersections. Now, before we dive into any of the detection and details, I want to go over a little bit of the permissions and alerting that are available within TrafficLink. So you can see on the top right here, we have our little user, and you can see the organization, some of the settings, and user management. So if I go into user management, we can see everyone who has access to this particular organization. And you can also see any of the alerts that they receive. So as Andrew was saying, we want to alert you of any issues that the intersection might be running into. Maybe there's a power loss, or the intersection's gone into flash, possibly a communications issue where we're not reading from the controller. We want to let you know about that as soon as possible, so that instead of having somebody call in and complaining about an issue, you're able to be proactive and manage that issue and resolve it, hopefully before anybody even notices. So I'm going to use Chris as an example here, and we're going to talk a little bit about some of the permissions. So we give you 4 different options for user management, and when you first set up an organization, you would be the administrator, and then you can add anyone else in here that you want for access. Maybe you want to add a contractor, for example, who does some of your installs. Maybe you give them view only with video so that they can see all of the details, but they're not able to make any changes to configurations. Read and write gives you access to make any changes as you need. And the difference with administrator is you can add and remove users as you see fit. So security is built into the platform from the ground up. And then all of the alerting here, you can customize which alerts you want people to receive. So something like if a detector's stuck on and that could be, you know, a loop or a puck. We're going to let you know about that. Same thing with flashing lights and power loss. Maybe you have preamps configured at that intersection and one of the preamps are stuck on, or maybe something happened at the intersection. There was a crash or collision and you want to take a look and get an idea of what's going on there. And there's a reason the preamps are stuck on, because you have emergency services working there. And then other alerts for if there's IP conflicts, maybe you have multiple devices connected at an intersection. We're going to let you know about that, as well as any devices that have gone down. Now, there's a couple methods for receiving alerts. You can receive an emailed alert or a text message based alert. And the other neat piece here is you can actually set this up on a schedule. So in this case, we've got Chris, who's set up to receive alerts all the time. He wants to be aware of anything that happens within the city of Quincy. Now, if he had maintenance workers potentially working either on weekends, or maybe they're doing the 9 to 5, or maybe some of them are doing call it a 5 to 2 a.m. shift, you can actually set up a schedule so that they only receive alerts based on their time. And that way they're not getting bombarded with alerts that aren't relevant to them at the moment. So that kind of covers the user management and how the alerting's all set up. If we jump back to our map, you can see as well everything within Traffic Link is controlled within the left tab here. So we're going to go back to the map and we're going to select a particular intersection. So we can zoom in and out and get a better idea of each individual intersection. And I'm going to choose Quincy Avenue and Southern Artery. Now, I like this intersection because it's actually a dual camera deployment. So it really shows some of the details of what we can do with our platform. So we've clicked on the intersection, we get a quick little Google Maps view, we get a little bit of the weather, we can see any of the devices that are connected here, as well as any active alerts. So no alerts right now, that's a good sign. If we go ahead and click on telemetry, we're going to be able to see all the phasing data and have an idea of exactly what's going on at the intersection right now. So this one's a pretty robust intersection, you know, a pretty detailed timing plan. You can see all of the left turns, through movements. We've even got some protected rights here. So the traffic signals piece right here is going to show you anything that's happening at the intersection, and that way you know exactly what's going on. You can also see the pedestrian signals. All of these are going to correspond to the map here. So we can see that the southbound is green right now. The head signals are all going to show whether it's, right now they're all on don't walk, but you'll see them change to flashing don't walk as well as walk. And down here we have the detectors. So right here we're showing you any detectors that are currently on, highlighted in the dark gray. Light gray means that there's no one in that detection zone. Same thing with the corresponding detectors on the map. You can actually see anything that's lit up in purple means there's something in that zone. And depending on how you set it up, that could be a vehicle, that could be a bike, that could be a pedestrian. That's all dependent on the actual setup and customization within the platform. We also give you an approach view. So the approach view is just a quick summary of all the lights and phases that are active right now. And we also give you a timing diagram. So a little more detailed here, but you can see exactly how long each phase is active, and you can see how long the detectors are being held down for. If we jump over to the actual video page, which happens to be one of my favorites, we're going to get a live view of everything that's happening on the intersection. And as I said in here, we actually have 2 cameras. So similar to what Andrew was saying, we've deployed 2 cameras at this intersection because it's a fairly large intersection and there's a couple slip lanes. So we want to make sure we have a really good field of view to get the detection working properly here. So right now we're just in the camera view. we can see what's going on there. If we switch to our detection view, we're going to get a multi-view of all the approaches, as well as our turning movement counts. And just have to give me a little moment here. We're currently working from home, so my internet connection can be a little intermittent. There we go. Just going to try a quick refresh and switch to the multi-view here. There we go. Much better that time. So I'm going to pull this up into full screen and give you a breakdown of how the detection works and what's happening here. So in the top left corner, we've got Quincy Avenue westbound approach. You can see these are our detection zones. So in the left turn here, or the through movements, you can see when somebody's in there, the detection zone lights up green. And when the zone's cleared, it just goes back to the default color there. You can see that we're also picking up different types of vehicles. So V1 corresponds to a light vehicle. And let's see if we have any heavy vehicles. So a heavy vehicle would be a bus, a large truck. They would appear as V2. And down in the bottom left here, we can see we've got a pedestrian crossing the road. And then in the bottom right, we have our turning movement count. Now you may notice we actually have another turning movement count up here. So once again, the reason we decided to choose Quincy and Southern Artery is it's kind of a unique setup. We're actually using one camera for majority of the TMCs and another for those views that are a little bit trickier to see. So we're actually using two cameras, two separate TMCs that combine together to give you a full suite of data. And as you see movements happening in the TMC, you're going to see this purple line pulse. So anytime you see a pulse, that is adding 1 to the count for that movement. And all the detection here as well is multimodal. As I said, you can set it up for vehicles only. We can detect cars. We can detect bicycles, pedestrians, trucks. And we're working to continue to add different types of vehicles. I know something we're looking at currently is e-scooters as they become more popular. And as Andrew was saying, with everything we do based on machine learning and AI, the more we see them, the better we're able to train our algorithm to recognize them and be more accurate in its detection. Right here, we have our Insights tab. And like Andrew was saying, this is where we see a lot of our ATSPMs, occupancy ratio, phase intervals, split failures and trends, some of our safety data. So this is all accessed through the Insights tab. We're going to dive a lot deeper into that because that is quite a large topic on its own. So we're going to dive deeper into that into a separate webinar. But what I want to show you here is how the TMCs actually calculate and what that looks like. So we're still in Quincy Avenue and Southern Artery, and the TMC page goes ahead and loads up. So we're looking at TMCs from yesterday. So you can see within a 24-hour total, almost 29,000 vehicles, 445 pedestrians, 10 bikes. So definitely not a bicycle heavy area, and small percent of truck traffic as well. And then we're giving you the AM and PM peaks. So these are all calculated just based on highest traffic volume per hour. Then we give you your individual counts from each movement here. On the volumes here, you can go ahead and change the graph to get a better idea of what's been happening at that intersection. So if we remove light vehicles, now we're looking at single unit trucks, articulated trucks, buses, and work vans. So heavier vehicles we're looking at here. You could also use the TMCs to determine, say you're in a bike heavy zone, maybe you guys want to look into implementing bike lanes in a particular area, partially for safety, convenience, that all depends on what goals you might have within a particular city. Now, jumping from insights, we can take a look at another intersection. So I'm actually just going to pull this up here. We can see all of the intersections within Quincy. And we're going to jump over to Washington and Temple. So if I go a little bit further down, we have our devices tab. So the reason I chose Washington and Temple is I've been given permission to access the controller here, and I happen to know the username and password. So we can see the controller. It's an M60 that we have set up here. What I'm going to do is remotely connect to that controller. So if I click connect, it's going to pull up a little telnet window for me, and it's going to ask me for the login. Perfect. So I've gone ahead and typed in the password correctly. So we now have telnet access right to the controller itself. And we can actually make any changes, change timing plans if necessary remotely. You don't actually have to go on site or send somebody else out to manually change things. On some controllers, we actually can give you a remote panel as well. So the remote panel is going to give you the exact same view that you would see if you were standing right in front of the cabinet itself, looking at the controller, but remotely. So we're able to do all of that cloud-based for you. And that really sums up a quick overview of the Miovision Traffic Link platform. These are a high-level overview of what we're able to do with our platform. As I said, you can get a lot deeper with the Insights tab and ATS-PMs, but we're going to save that for another presentation just because there's a lot of meat there. I'm going to pass this back to Andrew, and thank you guys for having me today.
Thanks, Rob. Appreciate it. Okay, so as Rob mentioned, we will be doing a separate presentation around the actual data itself. We're going to likely pull a case study in and really get in deeper as far as how not only cities, but a lot of engineering firms are also using this data. And in many ways, right? Some ways is to help justify funding. So whether we're working with FHWA on a grant, we've been successful with several grants across North America, partnering up with cities and engineering firms, using this data to look at CMAQ, for example, looking at congestion mitigation and the environmental impact that we can save from addressing congestion with detection and with some of the ATS-PMs that we provide. So in general, I think that'll be a very good conversation, and we'll have some pretty good examples of how we've worked with other partners, cities, engineering firms in the past. So I have a few more minutes here. So I would like, we talked a little bit about turning this, how we can continuously turn our video, take that video, retrain our algorithm, and push it out to the field. So I think it's important to actually look at a case study that shows this. And it's not always Milevision was plugged in and we blew their socks off. I think it's important to show ones where maybe we didn't meet expectations, but how we worked with the city to get them where they needed to be. And I think that we've done that in a lot of cases, and I think that's why Milevision is a strong player in this space. So we worked with Portland, Maine, who had some detection problems at an intersection. They tried many different types of detection. There's a quote from Jeremiah, who's traffic engineer at the city, around at this dual camera location. You can see here at the image, it's a complicated installation. We had 2 cameras deployed out there. When we look at detection accuracy, we went through the TURL certification, which is the Traffic Engineering Research Laboratory in Florida, which is their APL. It's a very robust, very long APL process where they really put you through the ringer, both on a hardware standpoint as well as on your detection capabilities. And they wanted to be able to see 98% accuracy in a lab environment. So the approach Milevision took from that was like, okay, well, in the Northeast, it's not bluebird skies every day If we can be 98%, if our goal is 98% in the lab with them, we should have a goal of 98% in the field in all weather conditions. So when we first installed into Portland, Maine, out of the gate, we were at 97.3 real world accuracy. And we had some discussions with the city. Our technical account manager, who worked that territory at the time, worked with the city in order to make some changes, make some tweaks, update the algorithm. And you can see there was a few different kind of, algorithm updates, and we went from a 2.7 error rate to a 1.7 error rate. So getting it to 98.3%, which if you look at, you know, the TURL accuracy certification score of 98 in the lab, we want it to be 98 in the field at a very challenging dual camera intersection. So kind of talking about those over-the-air updates and working with customers on their deployments and how we can improve them. This is a great example of how Miovision did that. I think it's also important to know, here's an actual snapshot of the intersection. I think it's also important to note that there's a few things that we didn't highlight that are fairly industry standard. If for any reason we can't actuate a zone, we can't see something, we get blocked, we go into fail-safe mode and it does go into recall. One key point about that is we don't put the entire intersection into recall. We would only put the specific movement that we're looking at or that we're having issues seeing into recall. And where that comes into play is at a fully actuated intersection, or if you're running an adaptive signal control out there. That's kind of one of the pieces that I wanted to highlight. The other thing that I missed briefly as well is normally our deployment height max is 35 feet in New England just because of the bucket truck height reach. And then as well as we don't like to go over Ocean State and Milevision. We don't like to go over a 10-foot pole extension just for stability and wind purposes. So the majority of the deployments you'll see in New England will be probably anywhere between 30 and 35 feet. So at the end here, I'm not going to read this, but we had great feedback working with Jeremiah at the city of Portland, Maine, in regards to this intersection. We said, put us at your most difficult intersection and let us prove to you what we can do. And at the end, even though out the gate we maybe had a little bit of a hiccup, at the end of the day we supported Jeremiah and what he was trying to do and got them where they needed to be. So we're at the Q&A, so I'm going to pass this off to, I know we do have some questions and it's not too late, so I encourage anyone, whether it's related to a project or related to video detection in the past and maybe some of the obstacles that you've seen or faced, please add them in. I know there's been a few come in. I'll let Ian take it from here.
Thanks a lot, Andrew. It's Ian Davis, Andrew's colleague in New England, working with Ocean State Signal. We have had some good questions come in. The one that really resonates with me, being from Canada, has to do with weather. Have you experienced any camera housing cracks or defects from the New England winter and summer weather conditions? And the answer is no. There have been no cracks, no physical damage due to weather. Our algorithm, artificial intelligence algorithm, has also continued to learn and teach itself to track vehicles in very different weather conditions, rain, snow, even in some cases, ice on the lens. Obviously, being Canadian, I think it's fair for me to say that we experience similar winters to New England, although I would say you guys get a couple of feet more snow than we do. Temperature is certainly close to the same. And the other thing is we're working with Panasonic right now, who makes our lens, and we will be coming out with a heated camera lens sometime in August of this year, just to further increase our accuracy. Let me just, and please do feel free to write in any questions that you do have. We've got a few more here. Can you use the Miovision solution on existing city fiber for communications, or do you have to use it with your cellular solution? And the answer is yes. If you have an existing fiber deployment, you can certainly use the city installed fiber connections and third-party communications. Oh, here's a question that that Rob did touch on in his presentation. Do all users have full administrative privileges, or there are levels of access in the system? And there are levels of access. You can grant certain people read-only access so that they can have a look at the reports, and then you can grant other people full administrative editing privileges to the suite as well. Can your system be installed in TS1, TS2, and ATC cabinets? Yes, for TS1 and TS2 today. ATC cabinets are on our roadmap. We're receiving our first ATC cabinets to test right now, and we're building integrations to be able to fully integrate with an ATC cabinet before the end of this year. Keep them coming, folks. Keep them coming. Can we pull config file and data counts from the device at the intersection? Not today. Our platform is cloud-based. However, we are prototyping a local version that can do this, and it should be available sometime in Q3 of this year.
And Ian, is it okay if I jump in on this question?
Please do, Andrew.
So when Miovision built our configuration, we built it off of the cloud to allow agencies to remotely configure intersections, meaning initial configurations, or if there was a storm and the camera shifted or there's construction, not having to physically go out to the intersection and actually make those changes. That being said, we learned fairly quickly that having an on-prem configuration tool is important to agencies. So we'd actually currently build a portion of it, which allows agencies to go out and to tweak existing configurations locally. So plugging into the controller, similar to how you may be familiar with video detection being configured today. So you actually can go out to the intersection and make changes to existing deployments. The only thing you cannot do today is actually create those initial deployments roadside. That being said, as Ian just mentioned, we're building that functionality and it will be available next quarter. So I just wanted to make sure that after the initial deployment's done, everything else can be done at roadside except for the initial configuration, which will be available next quarter.
Thanks, Andrew. Another question just came in, and it is, we had a client that was hesitant about us specifying Miovision because of training concerns. What should designers tell municipalities about the availability of training for their staff? And great question. I'm going to ask Rob Molinaro to address this one, as he is currently working on training a couple other very recent installations in the Massachusetts marketplace. So Rob, maybe you could address what a client should expect from training purposes.
Yeah, gladly, Ian. So the good news here is part of my role as the technical account manager is to offer hands-on guided training, whether it's a first touch on the Miovision equipment and the platform, or if it's going a little more in depth with some of the configurations. So to ease your concerns, I mean, the training we offer is entirely unlimited, and that's completely baked into the role I do. So in the New England area, I'm completely available to help out either end users, agencies, DOTs, anyone who's looking for training. We are here to help with that, and that's been a big component of a lot of the feedback we get, that we're very available. We've got a great support team, and again, we go in depth with the training. Whatever you guys need, we're there to help out with.
That's great, Rob. Thank you very much. And Rob is in the process of setting up, as I mentioned, some onboarding training sessions with some Massachusetts installations as we speak. So that's all of the questions that we have had so far. I would encourage you, we still have a couple of minutes left. If there is another question from the field. Oh, hey, there we go. Oh, Gary. Well, Gary, you're welcome. Thank you. If you do have any questions that haven't been answered on this webinar, please feel free to reach out to your representatives at Ocean State Signal. We are partners, or also, I believe on the concluding slide, you will get Andrew, Rob, and my contact information, and please feel free to reach out to us as well. It's been a pleasure presenting to you today. There aren't any more questions, so I will hand it back to Andrew to wrap up.
Perfect. Thank you, Ian. I appreciate it. So firstly, I didn't want to jinx it earlier in the presentation, but my two kids, I definitely owe them some ice cream. They've been quiet this entire time, and my dog, which is miraculous. I don't know how that actually happened. So that's good.
My dog's getting a dog treat.
But at the end of the day, thank you, everybody. If there's one message that I hit on earlier and before we check out here, it's around the detection only side of things. I know that there's been, Milevision focuses a lot on the software and the stuff we can do, which help agencies address traffic congestion and safety and manage their network. But if there's any deployments that are detection only, meaning the customer doesn't want software, they just want detection, Milevision provides the ability to do that with no reoccurring cost while still updating the system and still have remote configuration capabilities, and two, able to provide TMC, turning movement counts, directly locally from the device that can be pulled back using existing communication networks. So out of the box, as detection only, Milevision can still provide counts data as well as detection with no reoccurring cost. The software is in addition to that. So I want to make that clear so everybody knows, because I know there's been a little bit of confusion there, but apart from that, we have 3 minutes left. There's no other questions. I want to thank everybody for taking the time to sit in our webinar today. Here you'll have our contacts, me, myself, Andrew Fonseca, Ian Davis, Robert Molinaro. Thank you for the demo, Rob. You did a great job. And Gary and Mike from Ocean State Signal, who can address any questions around pricing as well. So again, thank you, everybody. Stay safe, and we look forward to any follow-up conversations.